Assalamu alaikum and hello. Welcome to the Fundamental of Electronics course. I'm Jana Ibrahim, your instructor. What is electronics? When most of us hear the word electronics, these items such as television, laptops, mobile phones came into the picture. These are electronic systems, comprises of subsystems or many electronics circuitries, and these circuitries include amplifiers, signal sources, power supplies, and digital circuits. Electronic systems such as radios, televisions, and computers were originally constructed using vacuum tubes. The function of the vacuum tubes were to increase the strength of AC signal and to convert the AC energy to DC energy. However, vacuum tubes have several problems as they are fragile and very large. In the 1940s, a team of scientists in Bell Labs developed the transistor. Transistor is the first solid-state device capable of amplifying an AC signal. Transistor is smaller, more rugged, and consumes less energy than the vacuum tubes and has replaced vacuum tubes in many applications. Solid-state components are made of elements that are classified as semiconductor, and a semiconductor is an element that is neither a conductor nor an insulator, but rather lies in between the two materials. Semiconductor has resistive properties that under certain conditions can tune the semiconductor materials into insulator or conductor characteristic. Electronics is the science of the motion of charges in a gas, vacuum, or semiconductor. Today, electronics evolves around the development of transistor and transistor circuits. Microelectronics refers to the integrated circuit (IC) technology, which can produce a circuit with multi-millions of components on a single piece of semiconductor material. Since the first IC, circuit design has become more sophisticated and the IC is more complex. Device size continues to shrink, and today the IC can contain arithmetic, logic, and memory functions on a single semiconductor chip, which we call a microprocessor. The electronic components are categorized into active or passive depending on the function they are able to perform. Active components are capable to supply power into a circuit. They are capable of electrically controlling and amplifying the flow of electrical current, whereas passive components cannot. Active devices such as DC power supply, batteries, and AC signal generators are capable of supplying particular types of power to the circuit. They require a source of energy, typically in the form of a direct current, in order to perform their specific function. They are able to manipulate the flow of electricity in some way. Most active components consist of semiconductor devices such as diodes, transistors, and integrated circuits. Passive components can influence the flow of electricity running through them. For example, they can resist its flow, store energy for later use, or produce inductance. However, they cannot control or amplify electricity themselves. Resistors, inductors, and capacitors are examples of passive devices. Inductors and capacitors can store energy, but they cannot deliver an average energy greater than zero over an infinite time interval. A simple way to test whether a component is active or not is to measure the difference between its input and output signals. If there is a decline in power, the component is passive. If the signal is amplified, it is active. We are surrounded by these tiny electronics elements in everyday life. They are hidden inside lights, sound system, computers, phones, cars, and many more. The passive component applications include microwave and radio frequency applications such as remote keyless entry system, which rely on inductors. Antennas are also passive and are found in radios, GPS devices, satellites, wireless modems and routers, public transport, and more. In most electronic circuits, there are two inputs. One is from a power supply that provides DC voltages and currents. The second is input signal or time-varying signals from a particular source often need to be amplified before the circuit is called useful. This figure shows the signal source that is the output of a compact disc system. The output music signal from the CD consists of small time-varying voltage and current. The power required to drive the speakers is larger than the output signal from the CD, so the signal from the CD must be amplified before it is capable of driving the speakers in order for the sound to be heard. Other examples of signal amplification include the output of a microphone, video signals from weather satellite, or output from ECG. Therefore, analysis of electronic circuits is divided into two parts, one with the DC input and the other deals with the signal input. In general, different equivalent circuit models must be used for the DC and AC analysis. The lumped element model is a set of assumptions that allow us to treat various systems as being a single element that behaves like a single entity. In an electronics context, the lumped element model allows us to treat macro-scale objects like a resistor as one or a few equations that relate what happened at its terminal. We can treat the object as being physically small enough that it all responds at once as a single unit over our timescales of interest. We can treat a node as a single point where two or more elements connect. In electronics, the lumped element model specifically means that the voltage to current relationship of a component is all that's needed to describe its behavior. The lumped element model is an approximation, not exact value. Still, it's an approximation that enables the rest of the study of electronics and can also be applied to other systems. The voltage shown in the figure is called an analog signal. The magnitude of an analog signal can take on any value within limits and may vary continuously with time. Electronic circuits that process analog signals are called analog circuits. An example of an analog circuit is a linear amplifier. The digital signal is a signal at one of two distinct levels with discrete value which is quantized. Electronic circuits that process digital signals are called digital circuits. In many electronic systems, signals are processed, transmitted, and received in digital form. Digital signal processing or DSP are now a large part of electronics. The figure shows a sinusoidal voltage superimposed on a DC value, so the notation would be as follows. The following notation is used to identify signal components in electronics. A lowercase with uppercase subscripts indicates a total instantaneous value. An uppercase letter with uppercase subscript represents a DC quantity. A lowercase letter with lowercase subscript represents a time-varying signal, and an uppercase letter with lowercase subscript indicates a phasor quantity. Throughout the course, the input and output signals will be used in terms of instantaneous notation, either AC or DC. The basic of electronic circuits are the semiconductor devices. For instance, the electrical characteristic of these devices provide control switching required for signal processing. That's all for the introduction of electronics. Stay tuned for other electronics video from me.